Told you we're going to have more fun. Think I was lying to you? So we have this nice system of inequalities. Now the first guy here, it's already solved for y. You're welcome. We see that it's greater than but not equal to, so we know it's going to be dashed. When I see the x squared there, that tells me that I'm dealing with a parabola. The negative tells me it's going to be an upside down parabola that is going to be moved up 6 units from the origin. So we know this is going to be a dashed curve. And because we have y by itself, we can see that it says y is greater than, so it's going to be shading above my parabola. So go up 6, an open point because we're dealing with an not equal sign. 1 squared is 1, 2 squared is down 4, 3 squared is down 9, and 4 squared is down 16. We can reflect these points over here to the left because of the symmetry that we have with parabolas. And then draw a nice dashed curve through your points, making sure that you put arrows on the ends. Now, if this were all I had, it says shade above, so it would be shading above all of this, so the outside part of the parabola with the way that it's oriented. Now the next part is this guy right here. So the way that this is written, and again, don't know why I have the 3 there, should have been a 9, so just change that, it'll be fine. So this is going to be a circle, and it has a center located at -1, +5, and the radius, see this is where I was having an issue. In my head I was having the radius be 3, and I wrote 3 instead of actually squaring that to be 9, so the radius is 3. Because again, remember, this is your r squared. This guy is going to be, this guy's going to be dashed 2. All right, fine. All right, so -1, +5 is going to be right here. That's my reference point. Radius is 3, so up 3, down 3, 1, 2, 3 to the left, 3 to the right. And draw a nice dashed circle through those key points. All right, so going back to the parabola, it's going to be shading above like this. Your circle has the less than, so it means you're going to be shading on the inside. So we're looking at shading inside here, 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 and here. So the region that's going to be common to both of those, where you are outside of that parabola, but also inside the circle, lines up with this little section right here. This is where your solutions are going to be. So that's the intersection of inside the circle and outside the parabola. Not too bad, right? All right, let's do one last guy right here. And before you freak out, take a deep breath. Some of these guys are actually kind of nice. If I look at x is greater than or equal to 0, remember that when you have just x, this means a vertical line. So it's when x equals 0, that's just going to be here along your x-axis. So this is x equals 0. Now it says greater than. So I'm just going to put a little note here saying greater than is going to be to the right of this. And when you think about just graphing on a normal number line, right? If I say x is greater than or equal to 0, you know you're going to be starting at 0, going to the right. Well, now you've got a vertical line. Go to the right, because there is no above or below when we talk about a vertical line. And then when I look at this, y is greater than or equal to 0. When it's just y equals a number, this is a horizontal line, and it says greater than or equal to, so it's going to be solid. So a solid line right here. And it says greater than, so that means we're going to be shading above. So if I were to stop with just these two guys right here, nothing else, my region of commonality is going to be everything that's here in quadrant 1. But we have more things to look at. So this guy, we have absolute value. And we know that the shape for an absolute value is a V shape. The negative in front would indicate that it's an upside down V shape. The -2 on the inside means we go to the right 2. The +4 means we go up 4. So that's going to be the location of our vertex. Right 2 and up 4. And with that -1, we can just use that as a slope going down 1 and over 1. All the while putting nice solid points here. All right. So here is my absolute value shape. Now this one says y is less than or equal to, so that means we'd be shading below. Keep in mind that every time that we introduce a new inequality to the system, it shrinks our region of commonality. So when I first had that vertical line, it was everything that was over here. Then the horizontal line came in and said, okay, you also need to be above. So that reduced it to everything in quadrant 1. Now by having the absolute value, shading everything that's below it, it's now going to be this region that's kind of stuck here, this little quadrilateral. But wait, there's more, and that's this guy. So this guy has a slope of 2, has a y-intercept of 0, -7. He's solid. We start down here at -7 with a slope of 2. So this is his graph. And it says y is greater than. So that means from here, you're going to be going up, be shading above. So you've got to be above the orange. So above the orange, below the purple, and you have to be in quadrant 1. And so that then makes it this region over here. That's your solution set. That bounded region, which happens to be a pentagon, and since all these lines are solid, all of these intersection points here, here, and here, all of those guys are also included, and everything that's on those lines forming that shape. Now, if a line had been, so examples that we had in the past, too far, this one. So when you have a solid line intersecting with a dashed one, this point of intersection would actually be an open circle. Because in order to be a solution, it has to be true for both of them. So although the intersection point, it would be true for the parabola, it would not be true for the dashed line. That one doesn't apply. This one, both of these guys are dashed, so their points of intersection would both be dashed. So there you go. Hopefully that one wasn't too bad. Again, systems of inequalities, you have to know how to graph, and you figure out, do I keep it solid? Do I keep it dashed? Do I shade above or below or inside or outside? Sometimes you have to do a test point, but then you're really just looking for the systems, where do they have a common area? And once you have that, you're golden.